Welcome back to solving trig equations. We've got some harder trig equations here, and let's just dive in and see what they're about. So our first one, we notice the change here is we have that 3 theta. What we're going to see on these two examples right here are a period change. I'm going to see 3 sine waves before I hit 2 pi, which means I'm going to go around the unit circle 3 times until I equal 2 pi. So we're going to have to incorporate that into our solutions. So let's take a look and see what happens. So I'm going to start with my sine inverse. Since my trig is already isolated, and now I have 3 theta equals the sine inverse of root 2 over 2. So what I know is sine is going to equal root 2 over 2. So where does that happen? That's going to happen at pi over 4 and 3 pi over 4. The issue is because we have that period change, we're actually going to have more than these two solutions. If you remember, our original sine wave looks something like this, and we're using this answer and this answer. There's my pi over 4 and my 3 pi over 4. But because we're going to see 3 sine waves in that same time, we're going to see something like this. Sorry, it's a little off, but hopefully we get the idea. I'm now going to have, marker, 1, 2, 3, 4, 5, 6 solutions before I hit that 2 pi mark. So what we're going to have to do is we're going to rotate around the unit circle 3 times to get all of our solutions. So take a look and see what happens here. I'm going to take these answers, and I'm going to go ahead and I'm going to add 2 pi to both of them to rotate around that circle. To do so, I need a common denominator, so really I'm going to add 8 pi over 4. So the next answer is going to be 9 pi over 4, 11 pi over 4. So there's one cycle, 2. Now I need my third, so that's going to be 17 pi over 4, and then 19 pi over 4. There's my third cycle. This is clearly larger than my 2 pi, but I've got one more step to go to fully solve this trig equation. I don't want to know what 3 theta equals, I want to know what theta equals. So I'm going to multiply this by 1/3, and that's going to give me theta, which means I need to take all of these, and I'm also going to multiply by 1/3. So when I do that, I multiply by that 1/3, this becomes pi over 12. This, 3 and 3, those are going to reduce, so I'm going to be left with pi over 4. 9 divided by 3 is 3, so that's 3 pi over 4. That's going to be 11 pi over 12, 17 pi over 12, and 19 pi over 12. If we think about it, 2 pi over 12, that would end up being a 24 pi over 12. So these are all of my solutions between 0 and 2 pi. Because of that period change, I'm going to get more solutions. All right? So you can go ahead and hit pause and give this one a try. Make sure you see how you do. We've got to isolate the trig function, go through that process, and see how you do. So what I'm going to do is I'm going to minus the 4 from both sides here. So 0 equals negative 1/3 cosine of 2 theta. So then I'm going to multiply by a negative 3 to cancel that 1/3. 0 equals the cosine of 2 theta. So now I'm looking at the cosine inverse of 0 equals 2 theta. 2 theta tells me I'm going to go around the circle twice. So cosine at 0, that's going to be 0. No, it's not. That's pi over 2 and 3 pi over 2. So I'm going to go again. I'm going to add 4 pi, so this would be 5 pi over 2 and 7 pi over 2 equals 2 theta. Okay? So then I'm going to go ahead and I'm going to isolate that theta. What I'm going to do here is I'm going to multiply by 1/2. Multiply each of these radians, so I'm going to get, can we see that? Nope. So we're going to write it up here. That's going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 equals theta. So these are all of our radian solutions that are going to equal theta that we can plug into our equation, which is going to give us that 4 here. Okay, again, we have the 2 cycles because of our 2 theta here. Make sense? All right, so this video is actually kind of lengthy. We're already at 5 minutes for those 2 examples. So I'm going to cut this and I'm going to come back and do these 2 later. Okay, cool. Bye.